This conference will now be recorded.
So in this course, we'll be discussing about one of the product solutions of F5, which is called as ASM. ASM stands for Application Security Manager. It is nothing but a WAF, Web Application Firewall, which helps us in protecting your application level attacks. So in today's world, it is very important that all your applications which are deployed in your environment are protected from various attackers who are existing on the internet. So this product is basically one of the F5 solutions which works as a WAF to protect your applications. So before we start with ASM, we will get into, we'll start the course by understanding how is a normal application traffic flow. When you try to access something on the internet or from your local machine, what all processes are basically involved in the backend for application to load completely. Then we'll understand how to build the F5 box. So initial configuration. What are the various methods, what steps we need to follow to build our F5 device. Once we are done with this, we'll start with a basic of traffic processing objects on F5. And after this, we'll start application components. In between, while we are discussing the application traffic flow, we'll also have a touch of HTTP protocol and how various components work there. After this, we'll be discussing about the web application vulnerabilities. Once we are done with this, then we will actually get into all the products or all various features which are involved inside the product. So what exactly each feature does, we'll discuss all those in detail. And along this, I'll also be performing labs and I'll show you how you can mitigate any specific vulnerability. So this was a brief of the course. So let's get started. Application traffic flow. Let's say you are a client machine and in here you're trying to access app.com. This is your application name.
Yep.
Basically on internet or for ease of use of the users, any application basically is represented by a name
Correct.
because it is always difficult to remember IP address of various applications. It is for very easy for a user to remember facebook.com instead of remembering that facebook.com relies on 101.1.10.1. On a single day, Facebook might be using a single service provider one, which is using this IP address. On the other day, it might change its provider, and let's say the IP gets changed to this. So again, we have to remember this new IP address. So it is quite similar to how nowadays we rely on phone book. Mobile is very important for us to get all the database of with the name and mobile number.
Yep.
So similar to this, in networking world, we have a big database which is being handled by protocol called as DNS, domain name system or service, you can call this. This DNS protocol basically works on port 53. So every protocol has their standard ports. The DNS works on port 53. Now the first things which comes into picture is a DNS protocol, which will map your domain name to an IP address. On internet,
Mm-hmm.
any communication that happens will be happening from your IP address. So let's say this client system is trying to communicate to the IP address of app.com. So in here, client only has first its own IP address, the source IP address. Now, next thing is it needs to find out the IP address corresponding to this app.com. To find out this, the first step which is involved is check of host file. So there is a file on your local system itself which has an entry saying that this domain name app.com is on, let's say, 100.1.1.100
Mm-hmm.
is relying on this IP address. The location of this host file is C drive, Windows, System 32, drivers, and etc. Let me show you example of this host file. So this is my location: C drive, Windows, System 32, drivers, etc. On this, I just do a right click, open with Notepad. So this is an example of host file which will have entries like what is the IP address and what domain name is corresponding to that IP address. So
Yep.
usually you'll find that any entry present in here will be with present with a hash value. So when
Yep.
it is hashed, it is something like it is commented. If you basically use this host file in situations wherein you have issues with your DNS environment. So you don't want clients to get affected in terms of if there is a problem with the DNS. So you can just create one entry on this host file, push it to all local machines so that this domain name gets resolved to the IP address that you mentioned here. Now, after this check, the host entry check, the next, if let's assume there is no entry in the host file, this first check is the host file. Next is your DNS cache. So on your local system also, there is a cache which is being maintained by the system. So this cache is looked for an entry for app.com to see if there are any DNS entries with respect to this app.com. If there is no entry in the DNS cache, the next part which is checked is a DNS query goes to your DNS server. So based on the response that we get from the DNS server, then client will try to communicate to that destination IP address. So for example, if let's say the IP address is 10.1.1 and the IP address that we get for this destination is 100.1.1.1. So now my this is how my packet is being formed at different layers. So at layer 3 now my I know my source IP and destination IP address. Then this packet is basically handed over to my lower layer. So now this DNS cache that we are talking about, how can we check this DNS cache on my local device? Let me show you. So on your command prompt, you type IP config slash display DNS and give enter. You will get records for various URLs that you would have accessed in a while ago. So the entries would be something like this name, what is the TTL of this record, and where it has to go. So this name is pointing to this CNAME record, and then this CNAME basically has a record which gives me this IP address. So now my client system knows that I have to send the traffic to this IP address. Once I know the IP address, then what I'll try to do is I'll check my routing table on my local appliance and see for sending any packets to this network where what is the route which is mentioned or what is the default gateway. If this destination IP address is not in my network, what is the default gateway that I need to send the packet to? So to find out this, I would use a command route print on my Windows system. So you will see the default gateway of my network, which is for any destination, any network mask, it is configured this IP address. So now I know that my IP is 10.1.1. This is my source IP. And destination IP that I have to communicate to is, let's say, 101.1.1. And my default gateway is 192.168.2.1 according to my network. So now my packet is being formed with 10.1.1.1 and 192.168.2.1. Now this packet is being handed over to layer 2. So after that, in layer 2, basically a MAC address is added as a header. So now I know my source MAC address. Say for assumption, I'll type this, and I don't know the destination MAC address where the packet has to be transferred. So this is wherein a protocol called as ARP comes into picture. ARP will translate this IP address to the MAC address. So sorry, in here, this will not be the destination. The destination will be my this IP, because my application app.com is corresponding to this IP address. But after I check the routing table, in order for me to reach out to this network, I have to send a packet to this. So your source system will initiate a something called as ARP request, asking who has this IP address. So when my default gateway or the router receives the ARP request, he sends back a response saying that this IP address is at let's say this MAC address. So now my packet which is being formed at the layer 2 will be something like this. Now, and this packet is then handed over to the physical layer to be transmitted in bits and bytes. So this is how the communication or the packets will get established between the client and my server. So in order to fetch any website, first a TCP three-way handshake will get initiated between the client and the server, and then the actual web application request or components will be fetched from the server. Now, whenever we talk about the web applications, right? So there are various components. You just type dot app.com. So corresponding to this, whenever you type this domain name, there will be multiple objects. So nowadays, most of the websites that you find will be either static or dynamic. So when I say static means the components of this web page remain constant. Dynamic means it keeps on changing. So when I call object could be like a JPEG image file, a PDF file, or maybe external link to a resource. So whenever you're dealing with the application traffic flow, right, these are various components which will be requested from your client machine and will be fetched from various servers. Now the question is, how do you actually find out what are these components? So when I access this app.com, what are the various components within that application which are being requested from my system to the external server? In order to find out that, I have various tools which I can use. One is Wireshark. Wireshark is one of the open source one of the best tools to perform packet captures. And then we have another tool called as Fiddler, or you can use HTTP watch. And at the end, there is a default tool include it in your browser itself, which is called as developers tool. So you can rely on any of these to find out what all components are being requested from your system. So let me just show you a fiddler or developer tools option. So let me open Google Chrome. So in here, I click on this icon, I go to more tools and then developer tools. Or there is shortcut option available which you can use, Control Shift I. Just click on developer tools, and after this you go to the network section. In here, let's say I type a URL called as abc.com. So as my website is being loaded, at the right hand side, you can see there are various components which are being requested at the backend. So unless all those objects are being fetched, you will not find that my website is completely loaded. So now in order to see these various components, you can even just click on one of these options and see the request headers, what is the response, to which server the request went to, what is the remote and IP address. So even though, see, I selected this object, I can see this is my domain name. But I tried accessing something else, right? I tried abc.com. It is still fetching the request from a different domain name. That's because how your application is designed by the developer. So if he has designed in such a way that the application will be fetching the request. So for example, in here you have a YouTube link or YouTube video link. You have option for fb.com. So these are various objects embedded on your website, and these objects have to be fetched from external server of that domain. So maybe abc.com, wherever it relies, um, it will tell the client that, hey boss, to fetch this object, you need to go to the FB server. So then client will initiate a connection to this FB server, send a request for that specific component, and this server will respond back the object. So unless this client has all the objects, the complete page will not get loaded. Guys, until this part, everything is clear, right?
Yes,
Yes.
Vinit.
So similar to this, you can also find option in Fiddler's tool, wherein whatever you are requesting, you can see the components here. Whatever request is being sent from your system, you can see the components here. You can even using these tools, you can modify the specific request. So for example, if this is being sent as get slash some specific component, you can edit this and send a complete different request as well. You can use this as a hacking tool as well. And then we have another tool called as Wireshark. In Wireshark, if you want to perform a packet capture, you just click on start and then what network interface that you want to perform a packet capture on. So for example, if let's say I'm connected through Wi-Fi, I'll just select that interface and click on start. The moment I click on start, see just in hardly 1 or 2 seconds, almost around at the bottom, you can see 2000 packets were captured. So packet capture is continuously running here. If I want to find out packets in my network belonging to a specific protocol, so I can even do a filter here. Let's say I just type DNS. So I'll see that, okay, from my system, what DNS queries are being sent to the DNS server. Or I can even do a filter with, let's say, HTTP. So like this, I can see various requests and what is the response. I can analyze various protocol packets, how the request flows. Okay, so now that we are quite comfortable with the various application components, let's discuss a bit about HTTP protocol. Let me stop this. Whenever you try open a browser and try to access a website, basically what you type, you just type like http forward slash abc.com or maybe f5.com or https colon, let's say sbi.co.in. So in here, this component is called as your protocol identifier, and this is nothing but your resource name. Let's assume that I have typed this big URL, https web.f5.com slash kb slash in dash us slash search.html question mark product equal to ASM. So in this, this will be termed as my protocol identifier, and this complete segment will be termed as my resource name. And then this resource name is again broken down into various components, wherein this will be called as your host name. and this will be your file name, or you can say as path where the file is located. And this search.html is your the request object, and after the question mark, whatever you find, right, that will be your query string. So it is very important that you understand these terminologies. What are they? So this is a parameter as well, which has a value of ASM. So in here, a very common example which I can give is whenever you type or open a browser, you just type, let's say, let me just first open up Google, and in here I type F5. So if you see the request carefully, see here there is a parameter q is equal to F5. So what I did is I just typed F5 on Google's website, and what has happened is this F5 is being sent as an input to the Google server, and then Google searched its complete database, found out what all references it has related to F5 as a keyword, and then it will send all those response back to your system, and then you will be able to see the various references related to F5. So be it F5 networks, or maybe it could be anything, F5 saloon. So wherever the Google server found a relation with respect to this term F5, it will give you all these suggestions back in your response. Now let's discuss about HTTP, packet request and response structure. First component of this HTTP packet is your request line. This request line indicates the method token. So whenever we are dealing with HTTP, there are various methods like get, head, post, put, delete, connect, options. So what method is being used to fetch your resource? And then what is the requested URI? And what protocol version are you using? So with respect to HTTP, there are different flavors like 0.9, 1.0, 1.1. Nowadays, most of the time you will find it as 1.1. So in the, for example, you just will get in the packet as get method slash admin dot php question mark category equal to, let's say, orders, and after this you'll find as HTTP protocol 1.1. This is the first line, which is called as request line. And next component is the headers. The headers will have varied information. For example, host. Host header will indicate what is the website name. So let's assume you're trying to access mysite.com. Do I need to keep the connection alive? Okay, connection, keep alive. What are the encoding methods that I can accept? Accept encoding. So for example, it will have gzip, deflate. So basically in the request, it is an indication of what are the capabilities of the server. What is the language that it will accept and
Hello, Vinith, you there? Hello.
guys, you can hear me, right?
Yeah,
Okay.
yeah. Now we can hear.
Okay. So the headers components will basically indicate what are the capabilities of the client or how it wants to communicate to the server. And after this, you will have a message body. Message body will have the parameters which are sent via the post method. So this is how your HTTP request structure is looking like. Similar to this, we have a HTTP response structure as well. So in the response structure, first component is your status line. The status line will indicate protocol version and what is the status code. Example would be like HTTP 1.1 and it will say as 200 OK. And then the headers field. This again will have varied content. For example, it could be specifying date, the server details, like say Apache. What is the content encoding? So in the previous page, when we saw the details about accept encoding, which provided the various ways in which the client is ready to accept the encoding of the data. So this content encoding will show the server has chosen what component. So for example, it will choose gzip. So then the client knows that the data which is being sent by the server is encoded in what format. It could have the content length. If there is any cookie which is being sent, so set cookie. So like this, various headers can be present. And then your message body. This message body is the actual response payload. It could have images like HTML, images, HTML file, images, scripts, videos. Now, same thing if you want to find out on the, let me just See in here, if I just choose one of the components, I can see these are my response headers. These are my request headers. So like this, I can find out the various header components within my HTTP protocol. And even in the packet capture as well, if you just click on one of the requests, and in here you have, in Wireshark you have a tab which will show you the data on how the packet looks like from layer 2 to layer 7. So if you click on or expand the layer 7 protocol, you will find the various details. What method is being used, connection keep alive, accept encoding, and then the response which is coming back from the server. So always remember, whenever you're dealing with HTTP, right, the way that server responds back is will be having 5 different series of codes. Hundred series just means that it is informational. 200 indicates a success. 300 basically indicates a redirection. 400 is client side error. 500 is server side error. So most of the time the codes that you will find in this series will be 200, 302, 404, 403, 503. 200 is what you need to look at. For the connection to be successful, it has to deliver the response code as 200. And then there are various HTTP request methods like get, post, put, delete, connect. The reason why I'm taking you through all this is these are the various application components, and this is what you will be dealing around when you are when you will be working on the WAF product. So you have to see what component, which component attack is being performed.
Yep.
What is the response payload? What is the request payload? So do you have any doubts in till this point of time?
Uh, yes, Vineet, I just want to know if we are required to know only those many codes and not the in detailed code for the HTTP.
The codes that I have shown in the previous page you are referring to?
Yes,
So those are most generic codes which you will find when you are trying to troubleshoot any application issues. So it is not mandatory that it is limited only to those. So it is how your application behaves in your network. So for example, like 404 you say, okay.
right.
So I'll give you an example. 404, you are trying to access a website and you just say http abc.com/test dot html. This request goes to the web server, okay, and web server is trying to find out this specific page or request object on
Mm-hmm.
on web server, but this does not have it. So in response, the web server will respond back with a status code as 404, which means that request not found. So I
Right.
so telling the client that, boss, I don't know what you are trying to request. Or maybe this user as a hacker is trying to access admin.php page. He knows that the
Mm-hmm.
backend is using PHP language, and he's trying to get to the admin page of the website.
Mm-hmm.
So the server will respond back with a 403, which means that, hey boss, wait a second, you're not allowed to access this page. Why should a user who's sitting on the internet should have access to this admin page? So it will
Right.
just respond back with the code as 403. And
Mm-hmm.
again, for some reason, let's say you have a proxy sitting in between. This is a client. So client sends a request to the proxy. Proxy, you have implemented a way of authentication. So it
Mm-hmm.
might send you a 407. So asking for authentication.
Okay.
So these are different ways in which, as you get along, you troubleshoot, you'll find various responses from the application. So you should at least have a basic understanding of does this response represent. So when you are getting a 403 from a web server, it means that you are not allowed to access that. One of the common example which I can give you for 403 is, let's assume client is trying to access application app.com. Okay, and this app.com, it has one of the components or maybe a video on its web page, which has to be loaded from YouTube server. Okay, but in your environment, YouTube is blocked.
Right.
So the client will come to you with an issue saying that, boss, this web page for some reason is not loading properly. So at that point of time, you would have to investigate the application component. So you might not know how this application is designed. So you would have to take a help of developer tools or maybe Fiddler or Wireshark and see what component is being requested in here, and with respect to that, what is the response code. So in here, if I just open this developer tools, so I can see the status code. Like this, you would have to see what component is failing in here.
Mm-hmm.
So that is the reason this main basic things you should be aware of.
Okay.
Okay.
Yep.
So I think we are running out of time today. We'll stop it here. We'll continue from tomorrow.
Sure.
Okay. Thank you
Yep.
guys then.
Thank you, Vinit.
Okay,
Yep.
thank you.
Bye. Bye.
Thanks.